Hi there, I wanted to recap something about these charts. They're called reaction coordinate diagrams to kind of help you out a little bit more on what's going on here. So on this left side, I'm going to show you a video. It's got potassium chloride in it, is what's happening in the video. That's this guy right here. And potassium chloride is this substance, KClO3. And what they're going to do is heat it up. So it's going to add heat, which means if we're inputting heat, this part of the demonstration is going to be endothermic. Inputting heat, endo. So there's the fire there. They're going to input the heat to really melt up the KClO3, and it's going to produce oxygen bonds. Not oxygen bonds, but oxygen gas, and it has bonds in it. These bonds are going to have a lot of energy stored inside of it. So right now we've got a potential energy. This is our reactants. They have a set amount of energy stored in the bonds. Remember, potential energy is stored in the bonds, and this chart is showing you potential energy as a function of time. So at the beginning of time, we have this much energy in our KClO3. Now I'm inputting heat. Now the heat is going to be stored in the new bonds, which is right here, the oxygen and the KCl. So I'm going to input heat, and when I input the heat, it's now going to be inside of these products. And so my products have a potential energy up here, nice and high. Remember, potential energy is the stored energy. We could do something with it. It's not the movement type of energy, it's the stored energy. So this is kind of the chart that changes from the reactants to the products. And now what we're going to do is add a gummy bear into that stuff. Hello, gummy bear. This isn't good for you. This right here is your gummy bear. And I just put it as sugar, so C6H12O6. So it's basically sugar. And that sugar, or any food that you eat, has an amount of stored energy in it. And that's why we eat the food, and our body breaks down those compounds to get the energy out of it. So at the beginning of time, we're going to start with its bonds have a set amount of energy here. So we're going to release this stored energy that's inside the gummy bear by putting this oxygen-rich environment. So if you put some sort of carbony thing in with a lot of oxygen, it does a combustion reaction. We'll watch it here. Here goes this gummy bear. You can see it creates a lot of light and a lot of heat. You can see the fire coming out the end. So this is definitely an exothermic reaction. I have produced heat and light. So now all of the energy that was stored in the gummy bear is now shot out of the container. It's no longer stored in the bonds anymore. And this graph is showing how much bond energy we have, potential energy. So my graph would look something like this for my exothermic. In other words, the amount of heat that was released, which we know heat to be Q, is this much. And so this is the heat released. When we look at the endothermic reaction, this is the amount of heat we had to put in. So I just try to recap that graph to maybe make a little more sense to you. Think about it as food. Food has energy, and our body breaks it up to produce that energy or use it in a different way. That's exactly what's going on with an exothermic. The opposite thing is happening with an endothermic reaction. We're going to take the outside energy and put it in and store it in the bonds. That's kind of what the plants do. Plants in our outside world will take carbon dioxide and air and all the parts and the sugars that they get, and they'll make food out of it. So they take all the energy, the sunlight energy, and store it in as the food. They're doing endothermic process. I hope that helps a little.